Hi everyone, I'm Janal Saeed, and for my Chemistry AA, I was assigned Topic 3, Paper 1. For my first Paper 1 question, I was supposed to find out the full electronic configuration for the element vanadium. So the first thing I did was I looked at my periodic table and looked at where vanadium was and found out that its atomic number was 23, which is the number of protons and electrons. Then I drew the electronic configuration chart. I know that 1s comes first, so the first thing I did was 1s2, then 2s2, then 2p6, then 3s2, then 3p6, then 4s2, um, then 3d3. What I did was we needed to have 23. So 1s2 plus 2s2, that's going to be 4. Then plus 2p6, that's going to be 10. Then 3s2, which is 12. Then 3p6, which is 18. Then 4s2, which is 20. Then 3d3, which makes 23. The reason why number B is correct is because this one was the only one that had exactly 23. And in number A, they put the 3D, that's 2, and the 4S, that's 3. But that's wrong because when we did the electronic configuration first, we found out that the 4S is 2 and the 3D is 3. And because the S orbital only holds up to 2, it does not hold 3. But the D orbital holds up to 10. Therefore, it cannot be A. The reason why number C is correct is option C is correct is because they wrote that the 3D is 4 and the 4S is 1. They gave one away from the 4S and they transferred it to the 3D, but we weren't supposed to do that. All we needed to do was put the 3D before the 4S, because the s orbital are the first ones removed when we form ions. Therefore, it makes it more stable and much better and more correct if we put the 3D before the 4s. Therefore, number D is also correct because it's incomplete, and they don't even have the 4s. Therefore, number B is correct because it has 23 and the 3D is before the S2, and the 3D has 3 and the 4S holds 2. As for the second question that I chose, I was supposed to describe the visible emission spectrum of hydrogen based on these options. So the first option stated that they are a series of lines converging at longer wavelength, which is unfortunately incorrect because the frequency of a wave is inversely proportional to its wavelength. That means that waves with a high frequency have a short wavelength, while waves with a low frequency have a longer wavelength. B stated that they are a series of regularly spaced lines, which is also incorrect because the hydrogen emission spectrum, um, um, the difference between each energy level is different. Like the difference between N1 and N2 is bigger than the jump from N2 to N3. The lines are not equally spaced, and they're also not randomly spaced. To jump from one energy level to another requires more energy and higher frequency. Then number C stated that they are a series of lines converging at lower energy. Since all that waves really are is traveling energy, the more energy in a wave, the higher its frequency. The lower the frequency is, the less energy in the wave. Therefore, shorter waves move faster and have more energy, and longer waves travel more slowly and have less energy. Therefore, number D is correct since it backed up everything that I have said. They are a series of lines converging at higher frequency, which is why number C and A were correct, because hydrogen has one electron, but it also has infinite number of orbits. When electron is provided with sufficient energy, it gets excited into its higher orbit. When this excited electron becomes to lower state orbit, it emits electromagnetic wave of corresponding wavelength. This forms spectral lines. Additionally, they converge at higher frequency because as electrons move further away from the nucleus, the electron shells become closer together in terms of space and energy. And so the lines converge towards the end of the spectrum. For the third question, I had to find out the full electronic configuration of Cu plus, and Cu2 plus, and then do the condensed version to find out which is the correct answer. So the correct answer was D. And what I did was I drew the electronic configuration diagram, and I got the full electronic configuration of Cu, which the atomic number was 29, so I did 1s2, 2s2, 2p6, which is 10, then 3s2, 12, 3p6, 18, 4s2, 3d9. Now this electronic configuration is incorrect because we had to use the rule that half-filled or completely filled d orbitals are more stable than those with one electron less. So the d orbital for copper is almost full. So we took one and we sent it over to the we took one from the 4s and we sent it over to the 3d to make it complete. And now 4s is half filled. Therefore, it makes it more stable than those with one electron less. So we know that the condensed version is 4s1 3d10 because we look at argon and then this is what comes after. Then to find out Cu plus, we just subtracted 1, so we just completely cancel out 4s1, and then to find out Cu2, we just subtract another one, so we're going to subtract 1 from the 3d10 because that's all we have, which is 3d9. So now we know that number D is correct. The reason why number C is correct is because they kept the 4s2 in the electronic configuration for Cu. They wrote that the 3d was 9, but they kept 1 from the 4s, which isn't technically correct because of what we've mentioned. And B is also is incorrect because they kept the 4s1 in Cu plus, and they did the exact same thing as C in the Cu. Number A is also entirely correct. Cu plus and Cu2 plus is incorrect because they got the electronic configuration completely wrong. They did not have the correct number of electrons. Last but not least, for the last question, I needed to figure out which which ion was fit this electronic configuration. So we have 4 options, and the electronic configuration we know gave us 28 electrons. So we automatically know that it's not nickel, because when we looked at the periodic table, nickel had an atomic number of 22, and if we subtract 2, that's going to be 20, so it's not it. And we know it's not cobalt either because when we looked at the periodic table, it has 27 electrons, and when we subtract 3, it's going to give us 24, which still won't be the best fit. So we're stuck with B and C, which are copper. So when we do the electronic configuration for Cu plus 2, we know that copper has 29 electrons when you look at the periodic table, and then we're going to do the electronic configuration, and if we subtract 2 from 29, we know it's going to give us 27. So we're stuck with B. When we do the electronic configuration for copper, we know that it's 4s1 3d10, and I already explained in the last question about the half-filled orbital, so we should know how to do the electronic configuration for copper. So after we subtract 1 from 29, the s orbital loses 1, so we're left with 3d10, which gives us 28 electrons, which fit the electronic configuration done in the question. Thank you.